at this point, you've had a moment to look at a radar image here. And so, yes, I think we can be done now, right? There is a problem with radar coverage over Western North Carolina. But let's get into it here. There we go. All right, so a lot of people have noticed for a long time that there are, in fact, lots of gaps in low-level radar coverage. Get rid of that, too. There we go. In Western North Carolina. And so if you just pull up a radar scope and look at the different tilts here, this is what you're going to see. And this isn't any tropical event or anything. This is May from last year. And you see that we've got these lines, not lines, but we've got these azimuthal sectors that are not covered at low levels. So yeah, that's maybe a problem. All right. Well, other people notice this too. We've got our wonderful forecasters at the Greenville-Spartanburg National Weather Service Forecast Office. Some of them are online now, so I have to be very nice. But this is from NWS Chat, and today here is actually just last month, February 16th. And so there's a lot of text there. So let me highlight this little piece and make it bigger because maybe you can see it better. He says, it's always tough to assess storm structure as activity moves through the mountains due to beam blockage. So yeah, there's a recognition there, even though perhaps NOAA folks can't come right out and say it, at least not on the clock. But yeah, in private, everyone will recognize, yeah, we have a problem here in Western North Carolina with our radar coverage. Well, there's a long history of attempts to fix this. Back in 2017, because it's not that long ago, but my colleague and I wrote a proposal to bring a radar to Western North Carolina. We'll put it right on Bear Wallow Mountain. Sent it off to NSF. It was a $3.5 million proposal. Nope, take it back, $2.5 million proposal. And NSF said, wow, this is a fantastic idea. We should totally do this. But you don't really have the staffing for that. And okay, I have to teach a bunch of classes, so does everybody else. So we didn't get the funding. Oh, well. That same year, Congress passed the administration said, you need to do this. So the Weather Research and Forecasting Act came out, and that directed the Weather Service to study gaps in NEXRAD coverage over the United States. And so they did that. And they came back and said, yep, there are no gaps anywhere in our NEXRAD network. Our NEXRAD network is fantastic. There are no problems. Look the other way. But if you read this report, you get to the end, you're kind of thinking, why don't you see this? But you get to the end and they say, well, but we'd really like you to fund this and this and this. So yeah, you kind of see where that was going. They just, anyway, it's an interesting read. But what they did do was lower the elevation scans for several sites across the U.S., 10 immediately and a few more later. And GSP was one of those that had its low elevation scan lowered from 0.5 degree to 0.2 degrees, which directs the beam directly into the mountains instead of slightly above. So, okay. So we still have this problem. And recognizing this and some other problems, especially in Charlotte and then again in Eastern North Carolina, there's a grassroots effort that calls themselves the North Carolina Radar Project, or NC Radar Project. And so they roped a bunch of people in to go to a meeting in Raleigh. And we met with the state emergency management folks. We met with some folks from NOAA and the Radar Operations Center and some General Assembly representatives, specifically Mike Clampett. And the agreement there was that, yes, we should go after funding to get a radar in several spots in North Carolina. Some folks had a goal of Charlotte, some folks had a goal in the East, and I raised my hand and said, how about the West? So anyway, that's the NC Radar Project. And what came out of that last year and a half ago was House Bill 985. And we have a lot of text, but I'll highlight the pretty parts here. It is funds for a radar at UNC Asheville and 2 other places. But the funding would go through UNC Asheville. And all we asked for was $17 million, plus $250,000 a year for 20 years. Well, that particular short session got limited to, I think, $2 million per requester. So obviously this didn't make it. So we tried again, and this time we are asking for only $18.6 million. Inflation, right? So that is currently working its way through the Appropriations Committee for a new bill that would be introduced in the next long session. So we'll see. We're also trying to get some federal partners to kick in some cash, and we also take Venmo and personal checks. But it dawned on me, these folks are going to give us a lot of money if they decide to do this. Maybe we should actually see if there really is a radar gap in Western North Carolina. It's fairly well established for Charlotte. But so I thought, what? Wouldn't it be nice if we had a rain event, like a widespread rain event, right? And we could compare rain gauges with radar. And so we got a storm. And let me point out some of these pictures here. So this is my family. This is the French Broad River, and this is just down the street from my house. And this big tree, a few hours later, is this big tree. So that branch there is that branch of the big tree a few hours later. And there's a speed limit sign, 35. So again, just down from my house, we lost some trees, and I sat on some. And so, yeah, this was a great event. And this is something to watch here. On the left, you've got the base reflectivity from the Greenville-Spartanburg radar, KGSP. And on the right, you've got the composite reflectivity at the same time. And there goes the whole event. Now, finally, oh, look, there's a tropical system. Let's watch that one more time, because it took me a long time to make it. There's your predecessor rain event. And then finally, here comes Helene. There we go. So quite a storm. And we got a lot of rain. So let's start to analyze this. So we have the multi-radar, multi-sensor platform or product that we have available. So the acronyms there are for the students in the room, which should be everybody, right? So let's look at 1 hour of total estimated rainfall from both, well, all the radar put together. So we've got Morristown up in the top left. We've got GSP, Greenville, Spartanburg, south of us, and then we've got Columbia down there as well. So all of this is put together, and this is radar only. So the MRMS product, or QPE product, also has the multi-sensor part built in, where we have numerical models filling in gaps, and we have gauge estimates inflating or deflating things. But this is only from the radar. So this is our best guess at what's going on from our radars. And what you will notice then is that we have, once again, this triangle here. And I accidentally clicked that. Let's go back. You're not supposed to see me yet. We've got this sector here where all the rain dried up. So it was very dry here in Buncombe County and Madison County. Of course not. But you also see from Morristown, we've got an awful lot of precipitation here, which is, of course, the beam reflecting off of the mountains. And so okay, let's keep going then. I do know that it was in fact raining here, and in fact more than the roughly quarter inch of rain that the radar says, because I was out there measuring it. It was really raining at that point. So something's going on here. We're underestimating the rain likely. So MRMS also has this quality index. Now, there are two components to this. The basic idea is that it indicates uncertainty in the radar QPE estimate, quantitative precipitation estimation. And so there's a fixed component that accounts for beam blockage, and then there's a variable component that looks at the beam height, and that's going to be a function of various aspects of the freezing level, which are accounted for using the RAP model. You figure out where the freezing level is. But what you can see then is that we've got this piece of Buncombe County, maybe a bit of Madison, where we have some poor coverage. Eastern Buncombe and in Henderson, also some poor coverage. The rest is actually pretty good. Okay, sure. Well, let's add everything up. So this is 72 hours that encompasses the entire rain event. from 0Z on the 25th to sunny skies. And what you see is that we got a lot of rain, according to the radar here. Some of this is an artifact of the fact that the beam is running into the escarpment here, so there's always a problem here with rainfall estimation. But again, lesser rainfall in Buncombe County, even lesser in Madison. But we've got a whole lot to the right, to the east of us in the mountains and then along the escarpment. Let's take a few spots and then compare that with some rain gauge locations. And my personal favorite weather station is here at UNC Asheville. And our tipping bucket rain gauge measured 11.43 inches. And the radar estimate is 9.09. That is a 20.5% undercatch, well, underestimate from the radar compared with our gauge. Well, surely that's just one spot, right? Let's look at Mount Mitchell. And apparently the rainfall at Mount Mitchell depends on who you ask. But this is for this 72 hours from the Econet measurements. I guess they got some rain before. What was the total? 31 inches or something?
31 was at the raw station you did.
Oh, beautiful.
24 is Mitchell for the binder.
Oh, all right. So, okay, at 3 a.m., I don't know. All right. So, yeah, again, a 23.5% underestimate from the radar. All right. About one of Dr. Miller's gauges out of the Great Smoky Mountains Rain Gauge Network. This is number 107 out here just north of Clyde. Again, the gauge measured much more precipitation than the radar estimate at minus 28.6%. Well, all right. How about Bear Wallow Mountain? Right in the big section of the higher estimates here. 26 inches of rain at Bear Wallow, and the radar only got 17. All right. So it missed a third of that. Okay. Oops. Well, surely the QPE estimate must be incorrect because this is happening everywhere, right? Well, let's look at Anderson, South Carolina. The gauge measured 8 inches and the radar got 10.86. Oh, that's an overestimate. Okay. Now, I'd like to look at a whole bunch of sites and then walk you through it for the next 4 hours, but let's keep going. Let's focus on UNC Asheville here and look at how the estimates vary over time. So it's a complex plot. You've got time on the x-axis, and that's UTC time. The y-axis on the left shows you that these are the black and the red lines. These are rainfall rates. So the red one is from the radar. The black one is measured from our tipping bucket rain gauge here. And so you see this huge spike up to 130 or so millimeters per hour. Keep in mind a millimeter is 25.4 inches, so we're looking at 5 inches per hour, give or take. And at the same time, the first floor of our building, note that there is a ground floor, a first floor, and a second floor. The first floor flooded here on campus when this happened. So we got roughly 3.5 inches of rain in the span of an hour and a half or so. And that was just the predecessor rain event. All right, then we keep going, and let's actually focus on a couple of sections here at a time. There we go. So again, big rainfall rates. The radar actually does a pretty good job keeping up with the gauge for a good deal of those heavy rainfall events. And in fact, if you look on the right now, on the right y-axis, you've got the gauge total in the blue and then the radar total in the green. So the radar actually overestimated slightly for this section here. All right, let's go back to the big section, or sorry, the big plot, and focus on the latter half, 2/3. And once again, we've got rainfall rates, but notice that the gauge has a higher rainfall rate than the radar. So the radar is underestimating these smaller but continuous rainfall rates. And as you see the accumulation plot here, you'll notice that the green and blue lines are diverging as you go on. Okay, so that means that the gauge is getting more and more rain compared with the radar. All right, so the question then, is there a gap? I don't know, but we might think that perhaps there is. There's likely a substantial underestimation in the mountains. You also have to remember that all rain gauges underestimate rain, especially tipping bucket rain gauges. They are terrible rain gauges, but they're automatic, and that's very nice. Okay, no going out there in the middle of the night. So the real rain that fell was definitely higher than what we're measuring. All right, and the big problem here is that, what if we lost our real-time observations? Has that ever happened? Okay. If we lose those observations, our poor forecasters and hydrologists are not able to figure out what's going on unless they look at the radar. But if the radar is underestimating things, oops, we have a real problem. This was a huge problem with Tropical Storm Fred when we had all that flooding out to the west, and our very own UNC Asheville station didn't work at the time, which I feel terrible about, antenna problems. But yeah, that's all they had. So there's a lot more work to do. I want to do more site comparisons. And for the students in the room, yes, we will be doing some statistics on this stuff and hypothesis tests. And there's also clearly an azimuthal dependence. And we also should look at the beam height above ground level, because one of the problems is that we don't see low-level stuff like rotation. All right. And lastly, public service announcement, join Kokoraz. I'll take maybe half a question.
This confirms the question someone asked me yesterday about one of my thoughts about MRMS. It is lead feed blockage, and I blame you. So I'm curious, because I love MRMS. So there are other gridded products out there, like Prism, GridNet. NCI has one technically called N-Time Grid, but if anybody from NCI is online, cover your ears. It's not that great for preset, but there are other gridded data sets out there for preset. And I was wondering if you could look at that and see if there's a way to help fill in this sort of gap, as maybe a combined product. Or I'm just curious if you looked at any of those.
I have not, but I would love to. Go ahead and send me a list of URLs.
Well, it's clever.
All right, sounds good.